Hi guys. Here I am coming at you from my basement this time. I realized that most of my videos are just me and my hands, and that might not be so much fun. So I thought maybe some of you, just some of you, might like to actually see me. So here I am. I'm in my basement because I don't have a whiteboard, but I do have a washing machine. And it's top loading. So lucky for me, this is actually working pretty good as a whiteboard. So here I am with my makeshift whiteboard in my basement, here to talk to you about some special cases with dots. Special cases. So you did dots the other day with Mrs. Van Rossum. So dots is difference of two squares, and you make a double bubble with different signs and that whole jazz. And it's pretty simple, I think. But the trick is sometimes dots can be factored again. Yeah, that's right. Sometimes there's more there left to do. So I'm here to show you some of those special cases. All right, so let's start with the first one, x to the fourth minus 1. So first thing we look at, we've got a binomial here, right? So when you see a binomial with a difference in the middle, you're going to want to question, is this dots? So we figure that out by looking. We have an even exponent, right? Even exponent means that it's a perfect square, so that's good. We have a 1, which is also a perfect square. So we have our two squares, and then we have our minus in the middle, checkmate, which gives us our difference. So we have a difference of two squares. Now, I'm sure Mrs. Van Rossum covered with you that a variable being a perfect square, all it has to have is an even exponent to be a perfect square, because to get the square root of it, all you have to do is divide it by 2. So that's why it has to be an even number. So in this case, we do have a dots. So we'll set up our double bubble with different signs. And then we take the square root of each term and put it in its corresponding spot. So corresponding spot, what I mean is square root of x to the fourth. 4 divided by 2 is 2, so you would have x to the 2. And corresponding spots meaning this is the first term, so you want those to be the first terms inside your parentheses. Right? And then the square root of 1 is 1. So now normally you'd be like, all right, guy, done, did it. But we're not done because we have dots again. Yes, we have dots again. We have x squared, which is a perfect square, and we have 1, which is a perfect square, and we have a difference in the middle, so this one can be done again. So you're going to have to double bubble for a second time, different signs, follow the same rules. Square root of x squared is x, and the square root of 1 is 1, right? And that is finished. You can't do anything else with that. But just like when we simplify radicals, we can't forget about the guy in the front, right? This guy we already took out, so we have to remember to take that down. Okay, and then this is your final product there. Okay, factored fully. So let's try another one. X to the 8th is a perfect square because that's an even exponent. Bam, difference in the middle. Perfect, perfect square, perfect. Bam, I love everything about it. All right, it is a difference of two squares, so we're gonna double bubble, baby. Double bubble, different signs. And take your square roots. So the square root of x to the 8th, in order to get that, I just divide 8 by 2, which will give me 4. So we put x to the 4 in both spots, right? And then the square root of 16 is 4, so we're going to put 4 in both spots. And then check if you're done. Now the first one is a plus, so I know I can't do anything else with that. So I'm going to check up on my second one. But I have a difference in the middle, and then I have two perfect squares. So again, I have the difference of two squares, which means I can double bubble, different signs for that one. Take the square root of the x. So 4 divided by 2 is 2, so that gives me x squared for both spots. And the square root of 4 is 2, so I have 2 for both back spots. Okay, and now can I do anything else with it? Well, this is plus, so I know that's done. But this is minus. That's a perfect square. But 2 is just an even number, not a perfect square, so that's done. So all we have left to do is bring down what we took out the first time, and we're finally finished. So that's your final answer there. Okay, I'm going to give you one more, just because I'm not done with you yet. Make it a little bit harder. So let's see, x to the 4th minus 256. Boom. Now that's a big number, okay? Our perfect square tree with Matthew the monkey, if you remember, that had all perfect squares on it, only went up to 244, something like that. 225. It was 15 times 15. I only went up to 15. So the reason why I want to pull this one in is because it's bigger than that. So you don't know that it's a perfect square, so you might just want to walk away from it, but I don't want you to do that. Okay? Anytime I want you, anytime that you see a binomial, right, something that has two terms with the difference in the middle, I want you to check for perfectness. Okay? So we know that this x to the 4th is a perfect square because it's an even exponent. So now the only thing you have left to do is take out that chunky yellow thing that the school gave you and see if 256 is a perfect square. Right? It is. I know it is because that's why I'm using this example, but you might not know it is. So anytime you see a binomial with a difference in the middle and an even exponent, just check that number for me. Please just check it. Okay? Thank you. So it is. So I have dots. That means I'm going to double bubble different signs and take the square root of each. Okay? So the square root of x to the 4th is x squared. First one. So it's going to go in the front spots. And then the square root of 256 is 16. That's going to go on the other spots. And this is one of our special cases again, because I have a perfect square in the front, a perfect square in the back with a difference in the middle, which means we can double bubble this. Different signs. X squared, square root of x squared is x, and the square root of 16 is 4. Okay, I can no longer factor anything more, so all I have to do is bring down the first one that we took out, and we're done. Okay, so this is some of your special cases. I am going to give you maybe 2 or 3 to try on your own, okay? I hope that you enjoyed seeing my face today, because I certainly miss all of yours. I hope that everyone is healthy and happy, doing work, and taking advantage of this time off. All right? Miss you guys. See you soon. Until then, peace.